Question 6. For part 1, we're given the relationship between experimental values of two variables, x and y. It's given by y is equal to a times b to the power of x, where a and b are constants. So for this part, we need to transform the relationship, y equals a times b to the power of x, into straight line form. So what we'll do then is we need to take the log of both sides, and I want to take the natural log of both sides. You could actually take log of any base, that is going to work, but because part 2 we've got the graph of x versus ln y, we're going to take the natural log just to make things easier later on. Okay, so taking the natural log of both sides then, we're going to get ln y is equal to ln a times b to the power of x. So we're just going to use the product rule for the laws of logarithms. So then we're going to get ln a plus ln b to the power of x. And now for that ln b to the power of x, we're just going to use the power rule. So we're going to bring that x down in front. So that means we're going to get ln a plus x ln b. Okay, so that is our final answer then. So we'd have ln y is equal to ln a plus x ln b. Okay, so that is part 1. For part 2, got this diagram which shows ln y plotted against x for 10 different pairs of values for x and y, and it shows the line of best fit. So we have to find the equation of the line of best fit and correct to one significant figure the values of a and b. So we'll start by finding the equation of the line of best fit. So to do that, well, we need to find the gradient of it. So we're going to need 2 points on the line. So we'll take this point here, which is 0, 2.2. You could take any points, but you want to find ones that are easy to read off the graph here. And another point would be 2 and 5. So we've got our 2 points. So we've got 0, 2.2, and 2, 5. So our gradient then, well, that's going to be our change in ln y over our change in x. So that's going to equal 5 minus 2.2 over 2 minus 0. And 5 minus 2.2 is 2.8. 2 minus 0 is just 2. So 2.8 divided by 2 is 1.4. So that's the gradient of our line of best fit. And if we look at our equation down here, which we had turned into straight line form, the gradient is just the coefficient of x. So that means 1.4, there's 1.4 here, that's going to be equal to ln b. So now that we've got our gradient of the line of best fit, and we know a point on the line, we can work out its equation. So just remember the equation of a straight line is given by y minus y1 is equal to mx minus x1, where x1, y1 are just the coordinates of any point on that line, and m is the gradient. So we're going to use the point 0, 2.2 to make our equation of the line of best fit. We could use the 2, 5 or any other point, but because x is 0 in that one there, 0, 2.2, it's going to make things just a bit easier. So what we've got then, well, instead of y, we've got ln y. So our y1 is 2.2, so minus 2.2 is going to equal our gradient, so m, which is 1.4, times x minus x1. Our x1 is 0, so we're going to just get times x. And now we can just rearrange this to make ln y the subject. So we're going to get ln y is equal to 2.2 plus 1.4x. So now we can use this to find the values of a and b, because our 2.2, which we've got here, well, that is going to be equal to our ln a, and our equation of ln y equals ln a plus x ln b, and our 1.4, well, that was equal to the ln b. Okay, so now we'll go and solve for a and b. So we have then ln A is equal to 2.2, and we just raise both sides to be a power of e to get rid of that natural log on the left hand side. So we have A is equal to e to the power of 2.2, and we'll just bring up our calculator to work that out. So we have e to the power of 2.2, and that is equal to 9.025, etc. And we need that to one significant figure, so we have A is equal to 9. And now solving for B, so we have ln B is equal to 1.4, and so we get B is equal to e to the power of 1.4, and that equals, so e to the power of 1.4 is 4.055, etc. And so rounding that to one significant figure, we have B is equal to 4. So that is part 2 done. So now for part 3, we need to find the value correct to one significant figure of y when x equals 2.7. So we've got our equation for the line of best fit, which is there. So we just plug x equals 2.7 into that, and then we can solve for y. So what we have then is we have ln y is equal to 2.2 plus 1.4 times 2.7, and that equals, so we'll get our calculator back up, and we have 2.2 plus 1.4 times 2.7, and that's going to equal 5.98. So we have then ln y is equal to 5.98, so that means y is going to equal e to the power of 5.98, and that equals, so we have e to the power of 5.98, and that equals 395.44, etc. And we need to round that to one significant figure, so we have then y is equal to 400. And that is question 6.